Welcome back to the Anatomy of a Minecraft Model, lecture number 2, animations. Before the break we took a look on some simple animations. We made the core of the droid spin around itself, but we also took a bit of a more advanced example there when we had a panel, a solid panel extracting, and that was a side not a side, it was a child model to the side rather, which made it follow along in the side's rotation, which made sure that it was placed properly like that. But what we're going to do now is continue with the child models and take a further look on what they mean to our animations and our models and so on. So what I want to do here is create another panel. So like I said before the break, I wanted a two-segmented panel, so we want to have an outer panel as well, and I'm going to say, well, new model renderer, like that. So why do I want it to be two-segmented? Well, I want it to be longer, okay? But then you might say, alright, just make it longer. It's just do 10 there. But the problem then is that it will always be 10 pixels long, and that's going to mean that even when we retract it, it's going to be very long, and that's not what we want. That's what I want to prevent, and that's why I want to make it into two segments. So we're going to have the outer part here, and if we take a look on the box I'm going to add, we're going to add it as in the same way we do for the first one. So the size is going to be, oops, here we go. The size is going to be 8, 5, 1, that's the same thing. The location is going to be -4, -0.5, and -0.5 again. So it's the exact same thing that we have up there. So it's the same box because it's the same type of panel, but well, where we should put it might differ, but its rotation should be handled in the same way. When we change the rotation, it's going to spin back and forth. Okay. So where would I want to put it? Well, here we go. Panel outer dot set rotation point 0, 5, 0. Okay, this might sound very weird. So we should actually move it 5 pixels down. Why would we even do that? Well, if we take a look on the inner panel, what we do is we just place it well here, depending on the the side and so on. But if we want to add a panel, the outer panel as another segment, it would make very much sense to add the panel outer as a child to the inner panel. We'll see why when we run it, but we're going to add it as a child there, panel outer. And if we do it like that, what's going to happen is that when we have the inner panel, we just have it facing downwards because it's retracted. It's just normal along the sides of the droid itself. And if we have it like that, how long is this panel? Well, it's 5 pixels in height. That means that we want to place the outer panels 5 pixels further down, which basically puts it, well, 5 pixels down. We move it 5 pixels down so it actually attaches to the tip of the inner one, and that's exactly what we want. So let's take a look, just like that. And as you can see, we're using the same texture as we did for the inner one, so we don't have to make any textures. But now you might say, well, won't we have the problem we wanted to prevent? It's going to be very long all the time. Look at that. So the outer one is following along with the inner one's rotation, and that's exactly why we want it as a child. So now it's do time set night. The inner one is being rotated, and therefore the child of that one is following along in the rotation, and there we go. It's just a much bigger solar panel all of a sudden. Oops. But like I said, now it's big. It just goes down all the way, and we will just have a big solar panel all the time, and that's not what we want. That was exactly what I wanted to prevent. But the good part that we have now, because we have one inner part and one outer part, they are in two different segments. We can rotate them individually, so that's exactly what we're going to do. Even though when we rotate the inner one, the outer one is going to follow along, and that's exactly what we want. So let's take a look. What do we want to do? Well, I want to modify the rotation of the outer one. Rotate angle x. I want to set that to negative float math.pi divided by 2. Why do I want to do that? Well, we can take a look on the panel itself. When we move that outwards when we extract it, what we do is that we move it towards the positive half a pi, so that's positive 90 degrees, so that moves it outwards. But when we have the inner panel, what we have, if we would move that outwards with 90 degrees with half a pi, then that would, well, that would be very weird. The inner one would face downwards, and then the outer one would just go out. That's not what I want. I want it to go inwards, so therefore we rotate it in the opposite direction, which is going to make sure that we're actually retracting it and pressing it, and that's the thing I want. I want to have a long panel that, well, when it's being rotated inwards, it's going to sort of, you know, be retracted into a very small little thing there. We'll see in just a second here. There you go. So now we can't see it. Well, we can see 1 pixel here off it, and that's that part there, if you take a look. And now if you set it to day, time set day, like that, it's going to work like that. So as you can see, just because I rotate it like that, it's going to be 90 degrees compared to the inner one, but when we change the inner one, we will still have those 90 degrees difference, just because the outer one is a child model renderer to the inner one, and that means it's going to follow along with the rotations. And this is very, very important when it comes to animations. As we can see here, if we want the outer panel to follow along like this, we have to have it as a child. And if you work with some softwares like Technique, then you can't do something like this. So that's the problem with them, even though it might be good to when we make models for other reasons. But when it comes to animations, child model renderers are very important. But we haven't, well, done it properly yet, right? The inner part is extracting like so, but shouldn't the outer one extract as well? Yeah, I think that's a good idea. So what I want to do is that the inner one should extract, and when the inner one has extracted properly, then the outer one should continue the extraction, and all of a sudden we have a big solar panel. But when it retracts again, the outer one retracts, and then the inner one retracts, and all of a sudden we get to the state that we can see here. We set it to night, like so. So I wanted to, in the end, get to that point there, but we want it to be fully out, 10 pixels out, when it is in its extracted state. So what we're going to do is something similar to what we did before with the panel. So private array list model renderer, like so, and then we just do outer panels or something like that. Here we go. Create that array list here. Outer panels equals new array list model renderer, like that. And then it's just a matter of adding it here. But remember, we shouldn't render the outer panels, because, well, those are a child to the panel, which is a child to the side, and we're rendering the side. So we can have how many layers of shards as we want to. We can have a child of a child of a child of a child if we wanted to. And it's nothing weird. If we have a lot of rotations and animation, that might be something we want. But obviously, when we do so, it's getting more and more complex to do. So outer panels dot add, and then we add this panel outer like that. So maybe that should be called outer panel, and here we have panel. I don't know about naming here. So what we want to do is do the same thing as before. So model renderer panel in outer panels. And then we just do it in a similar way. But we obviously don't want the same rotation angle. If we do that, it's going to be very weird. If we could take a look on that, but it's just going to be very weird. So let's not. You can try it yourself. So instead of get panel rotation, what I want to do is do something like get outer panel rotation or get panel outer rotation. I don't know which one to use really. So either you think of it like the outer part of the panel should rotate, or you might think that the panel is the whole thing, and that one should have an outer rotation as well. So I don't know, like that. So now we can define that one, and what I want to do here is, well, simply return a value from return panel outer rotation. Yeah, let's call that outer rotation. There we go. So I just return a field there that I obviously will have to create up here. Panel outer rotation. There you go. But if we head over back here to the model drawer, to the model itself, then there's no real reason to set this value here. You might say, alright, but we need the default value. Yeah, but if we set it here, we're anyways going to override it here. We're just going to give it a new value. So what we want to do is just remove the part here, but what we want to do instead is add that as the default value up here. Yes, because if panel outer rotation here has its default value as being negative half a pi, then that's going to be applied here, if we haven't changed that value. So we can't do it up here because we would have just override it by 0 anyways if we had the get outer panel rotation to be 0 by default. So that's why I moved it over there. But now we want this code here. We need to make it much more advanced, because we shouldn't just rotate them at the same time or anything. I want the inner one to rotate first and then the outer one to follow along afterwards, and then when we retract it's the opposite, so the outer one just goes inwards and then the inner one follow along to complete the retraction. So how do we do this? Well, we will have to use a more advanced algorithm. So what I'm going to do here is say open inner rotation equals float.math.pi divided by 2. That's when the inner one is completely open. Okay, so therefore I'm going to put it there. Okay, so far so good. But what I want to do is, right, if panel rotation, that's the inner one, remember, if that equals to open inner rotation, that means it's completely open, because then it has reached its open state. That one, the value it can't go beyond, just because, well, we used math.min here. So if it reached that state, the completely open state, then, and just then we want the outer one to start extracting as well, because otherwise they would do that at the same time or whatnot. So if that rotation is correct, then start updating the inner ones. And the inner one is obviously panel outer rotation equals, and here we do something similar, math.min like before, but we don't use math.pi or anything like that. We use 0. And here we do panel outer rotation plus 0.02f. So why would we use 0? Well, remember, the outer panel is going to be affected by the inner one's rotation. And we saw when we didn't, back here, when we didn't add anything here, when we didn't have this at all, we saw that we had first the inner panel and then the outer panel just following along, because it was controlled by the inner one as well. And that's exactly what we want. In the completely extracted position, then we want the outer panel to be in the same angle as the inner one. Okay? And therefore, the difference between them, which is the rotation angle x here of the outer panel, should be 0. So in the end, when we're done, it should reach 0. However, in the beginning, it should be minus math.pi divided by 2, as we saw. Then it was completely retracted when we had that 90 degrees bend there on the panel itself. So that's exactly what we want to do there. So we want to reach all the way up to 0 by increasing the panel rotation like so. Obviously, if 0 is the maximum, the minimum is a negative number, and that's the float we have up there, math.pi divided by 2, so half a negative pi, like that. So what I want to do here is the opposite. So here's where everything is being retracted again. So float closed outer rotation equals minus float math.pi divided by 2, right? That's how it's being sorted. That's when it's completely retracted. And what I want to do here is just move the outer one. Remember, when we retract it, we want to make sure that the outer one has retracted before we do the inner one. So here we do it in the opposite order. So panel outer rotation equals, and remember, we use maximum here when we allow them to retract again. So math.max, and here I want to use closed outer rotation, which is the negative half pi there, and then panel outer rotation minus 0.02f. So as you can see, I'm just extracting and retracting at the same speed with both the inner and the outer at the same speed as well. But then we do the same thing as before. If, well, in a bit modified of course, panel outer rotation equals closed outer rotation. So if it has reached its closed state, then what we want to do is obviously start moving the inner one like this. So as you can see, the code for updating the angles are a bit more advanced. When we work with just the core rotation that just span around all the time, then we could just update it like that. We just increase it all the time. We didn't really care of anything else. But now when we have multiple things that should work depending on each other and so on, it might get a bit trickier to update the angles. But what we want to do when we animate something is, first of all, we need to update the angles properly like this. It might be quite advanced depending on what we're doing. Then we want to loop through and update that rotation for all the things we actually want to update it for, or maybe just for one single thing, is that what we want. And lastly, we want to set up the boxes and model renderers properly so these rotations applies properly. And to do so, we have to think of where should we add the boxes, how should we set the rotation points, and so on. What should be shards of what. So we have those 3 steps. Creating the actual content, the boxes and a model render, how they should be compared to each other. We have the well, when we set the rotation itself, and then we have the thing that is updating the rotation to be updated properly. Okay, so let's set it to day now. Time set day. So now you can see the inner one is being extracted, but as soon as the inner one reaches its outer state, then we allow the outer one to extract as well, like that. So now we have a 2-segmented solar panel that is first extracting its inner part like we saw before, but then when it reaches the end, the outer one is also following along. And just because the outer one is a child model renderer to the inner one, we will see that when we extract the outer one, no, not the outer one, sorry, when we extract the inner one, this one here, then what we will see is that the inner one follows along. So it's not like we have to update this one's angle just because, well, it should be moving along with the inner ones. And that's very, very, very helpful when we work with animations like this. So take a look here again, and then boom, like that. Sweet! So that's pretty much it for this solar panel here. I think it's working pretty well, and then you can just extend this even further if you want to have even more parts of the solar panels just extracting from itself and so on. Then it would be totally possible. If you've seen this Steve's Cards 2 solar panels, you decide one, the compact one. It's working in the same way here. It's just a lot of different model renderers that are shards to each other, so when the first ones, the inner ones, when they extract and so on, the outer ones is just following along, but when the inner one has done its extraction, sorry, then the outer ones will start to extract, and then the one even more outer than those, the shard to the outer ones, will extract and so on. And then when you want everything to retract, you just do it in the opposite order. So update the angles properly, set the rotations, and then set up the boxes so they work properly by giving the rotation points and boxes at the correct locations, like that. There we go. Right, nice. We have seen about rotations and child model renderers, and they seem to work pretty well. But what about moving things? Can we move things? Yeah, we totally can move things. It's not tricky to do. So what I want to do is head up here to something we already have. The where are they? The pillars. The pillars here. You remember the 4 little boxes, and then we had the you know, the top on top of those. Yeah, obviously, the top here. So what I'm going to do is, instead of storing it here, I want to be able to move the pillars. So I'm doing it in the same way here. So private model renderer pillars. And then if I just remove it from there, what's going to happen is that I can control the pillars because I save it in the field here rather than a local variable. Right. So what's the next step? Well, what I want to do is make sure that the top one is following along. So if I move the pillars upwards, then I want to allow the top to move upwards as well, so they are sort of connected. And you should know how to do this. So instead of adding the top to the parts here, what we're going to want to do is do pillars dot add child, and then we add the top here. So that's going to allow it to follow along. But now if we calculate it, if we have the pillars at -6 and the top at -9 compared to those -6, then what we will get is -15, and that's not where we want to place it. So what I'm going to do is just modify this and change it to 3. -3, that is. So therefore we have -6 and minus 3 more, that's minus 9 in the end, so the top will be placed on the same position as it were before, but it will be a child to the pillars one, which is very important, because then if we change this to 7, all of a sudden this will be at minus 7 plus minus 3, which gives us minus 10, which tells us, well, it's going to follow along. So if we modify the value of the pillars, well, then it's going to follow along. Nice. And if we update the rotation, no, not the rotation, sorry, the location of the pillars, then we can do it like this: pillars dot rotation point y. So we can change the rotation point. As you can see here, of the core, for instance, we set the rotation point, but we can modify it by just doing a rotation point y, for instance, and set that to something. I'm going to do droid dot get helmet position. The reason why I call it helmet is just to be able to refer to something. If you think about it, if you had the 4 pillars and then the top there on the top, of course, if you put those together, it sort of looks like some sort of weird helmet for this droid. So I'm just going to call it get helmet position there. So there we go. That's how you update the position. Very easy. You just use rotation point y rather than like the rotation angle like that. But obviously we need to create a get helmet position. But before I want to do that, what I want to do is just remove where is it? Up here, the pillars. The set rotation point for the pillars. There's no reason to set it there, because that's exactly what we're changing. The only part we're setting here is the minus 6 one, and well, there's no reason to. That's what we're going to update here all the time. So I'm just going to remove that because it's not going to do anything after all. Okay, let's create a get helmet position here. And we can just define this however we wanted to. We could have like, alright, if you're currently firing a gun, then return fire. Yeah, never mind, it's shooting. If it does that, then we want to return like a minus 10, so we moved it up a lot. Otherwise minus 6, so it's its default location, so it's like would move the helmet up and then shoot something. I don't know, we could do something like that if we wanted to, but that's not what I'm going to do. We can just define it as we want to. What I want to do is bounce the helmet up and down, so it goes upwards, then it goes downwards, then upwards and down, yeah, and so on. And I'm going to define this as in a bit of a weird way. You might think, if you know trigonometry, then it shouldn't be that weird. If you don't, well, then you will just have to follow along and understand as much as you can. Private float helmet position rotation, like that. So I'm going to control the position of the helmet by a rotation, and what I'm going to do here is just do helmet position rotation plus equals 0.02. So I'm going to rotate it, the rotation, wait, what? Okay, so what I'm going to do that for is returning it here. So return minus 6, that's with the default location, but then I want to reduce it even further, okay? Which means we're going to place it further up. Math.apps, and that's going to give us the absolute value, which means that we're always going to have a positive value, and then if we always take the negative of a positive value, we always get a negative value. So if we have, for instance, minus 5 here, we will still have 6 minus 5 rather than 6 minus 5, like that. Math.sin, there you go. So we take the sign of a rotation, and that's the helmet position rotation, like so. And what I want to do is simply multiply that by 6. Oh well, 5.5 actually, that's what I want. So what we have here is basically math.sin here of the rotation is going to give us a value between minus 1 and 1, and if we take the absolute value there, we're going to get a value that is between 0 and 1, and if we multiply that with 5.5, then we're going to get a value between 0 and 5.5, and if we have a negative there, we're going to get a value between minus 5.5 and 0, and then if we subtract 6 from that, we're going to get a value between minus 6 and minus 11.5, and that's the values I want the helmet to go well, float between. So if we run it now, we'll see that we're generating the position like so, and then that position is going to be updated here, yes, because we use rotation point y, and because we updated it so the the top is a child of the pillars, that top one is going to move along when we move the pillars, like that. Let's take a look. Okay. Look at that. So now it's moving upwards. So let's make it to a time set day. And then it moves down again, like that. It moves up. And it moves down. So it's very easy to just move these things. You just refer to rotation point Y or rotation point X and so on, and since the top one is a child to the other one, it follows along. So as you can see, having childs here is very simple and very easy, so we don't have to move both the top and the pillars, but the only thing we do is move the pillars and just like that. If you don't remember, the reason why all the 4 pillars are moving is because we just have one model renderer called pillars, and that has 4 boxes. So it's not like we have 4 different pillars, we have one group of the pillars already. We had multiple boxes, and then we have the top as a shell of that, and everything is just moving like that. Okay, sweet. We've seen rotations, we have seen movement. Can we resize things? Well, no, not really. We can't resize things properly. If we do it, we can sort of if we do very weird things, but we're not going to do that. But we can simulate a resizing. So what I want to do here is that this helmet here, all the pillars should always be connecting the main block. So the pillars increase in size now, and now when it goes down again, I want it to decrease in size. We can simulate that. How? Well, let's take a look what we can do. If we increase the size of the pillars, if we take a look here, they have 2 in height. What if we set that to 8? That's 6 pixels more. Okay. We head over to the texture here and give them 8 pixels more here. Well, 6 pixels more. Sorry. 1, 2, 3, 4, 5, 6. So all the way down there. There you go. And save it. Okay. So now they can be much longer. If they are much longer and we just want them to be small, we can just hide the rest of them inside the main block. There's no problem with hiding them there, so when the hat moves upwards, it's going to look like the pillars extract. So that's what we will have to do if we want things to change in size. It's sort of possible to do it in another way as well, but it's not a nice way and it's not easy. But it sort of is possible, but I would highly recommend against it if you can avoid it. Here we go. Like that. So as you can see, now they are getting longer, and then when we retract them again, they are getting smaller. But as we can see here at the edge, they are always the same length. And here we have a problem. I'll say there wasn't a problem with having things getting hidden inside something else, but there is a problem with one thing. We shouldn't have faces like sides of boxes that are in the exact same spot as each other. This is going to do multiple things. First of all, it's going to be bad for the rendering. The rendering don't know what to do and therefore cause problems. Just because it wants to render multiple things at the same spot. It don't know which one you should see. And the second part is obviously that it looks bad. Look at that, it's just blinking. We can see the pillars moving downwards. That's not what we want. So what we will have to do is moving them inwards a bit. But we don't want to move them there. We want them to be at the edge, right? Yeah? I think so, but here's the trick. Okay, we multiply them with 4 here to move them to the edges, right? We can multiply it with 3.995, for instance. That's almost 4. So that's going to move them in a tiny bit, but that's enough for the rendering code to realize, oh right, these shouldn't be seen because the main block is in the way. Is it enough for us to tell the difference? Well, we will tell the difference in the way that we won't see this blinking part, but we won't be able to tell a difference that they won't be on the edge, because the difference is so very tiny. Let's take a look. like that. So now it looks perfect, like that. But if you take a closer look here, we can't see that they are not in the edge. Can you see that they are closer to the center than before? No, we cannot. Look at that. There's no edge of the main block that we can see here, like that. Just because we have moved it just a slightly bit. We have moved it, as we can see here, 0.005 pixels towards the center, and that's too small for us to tell, but the rendering code can now tell, alright, the main block here should be on the outer part and should therefore be the one that is being rendered, whereas the pillars should, well, they should be rendered if possible, but they are hidden inside it. So that's something that you should do. So we avoid the blink in there, and it also works better for the rendering in there. So obviously we're not resizing the pillars, but we're sort of simulating that. However, if you can't fit it, so you want the pillars to be even longer than this, so they move all the way to the bottom, then you will have a problem. Then you can't really do this. Of course, you can have two sets of pillars that moves up in two different stages. So we have pillars inside the pillars, and then you make them a bit different like that. That's totally possible, and then you use the same trick so you can fit them inside each other like before. So we have a segmented pillar, so we can hide like three sets of pillars inside each other, and then they move up once at a time, like that. That's totally possible. So as you can see, when we work with resizing, it sort of gets a bit of a problem, but if we do something like this, we can at least simulate that. But rotation and movement is very easy, like we've seen before. Before we end here, we might take a look on one last thing. And when we test that later on, I want this to start moving again. So like I said in the beginning, I just disabled the movement so we could take a closer look on the animation that we made, but now we want it to start moving again like it did before. So let's head back here again to the model. So what I want to do is allow the core, you know, the green core that is spinning, to be different colors. Well, changing the color isn't really animations, but we can use that sort of as part of an animation that we modify the color dynamically. What I want to do for that is, well, I want to tell it to render in a different color. How do I do that? Well, what I'm going to do is remove the core from the parts. That means that it's not going to be rendered in here. That seems like a bit of a weird way to do it. We just want to render it in a different color. We don't want to remove it altogether. But the reason why I do so is so I can add a core at the bottom here. Dot render. Well, it doesn't matter. The only difference now is that we will always render it in the end. But if you think about it, that wasn't a difference. We added the core at the end anyways, and the order isn't really that important. I'm not sure it matters at all, actually. And there we go. So now we rendered it at the end. Why would that be a difference? Why would that be better? Well, what that allows us is to change the color in here. GL11.GL color 4F like that, and then we can set the color like this. Okay, so I'm going to set it to 1F, 0F there, 0F and 1, like so. So that's going to be a red color. We have full of red, no green and no blue. But like I discussed in the last lecture of the third course, the Fortune Minecraft one, if you want to modify colors properly to set it to specific colors, then it's much better if our texture is white or grayscale. So what we want to do is modify this part here. So I'm just going to select this part like so. There we go. And pick a white, not completely white, but almost. And the reason why it should be almost white is so I can add some noise to it to give it sort of a bit of scrambled color there, so it looks better in the end, like that. So now if I have white there and I modify the color like this, the core that I draw afterwards, I draw everything else in the beginning, but in the end I draw the core like that. The core should be red, even though it's white in texture. So let's run and see how it goes. Up here. Right, so now if we take a look, all of these cores are red, even though I put it as white in the in the texture, and that's just because we modify the color like that. But everything else is being rendered properly just because we modify the color just before we draw the core, not before we draw anything else. Otherwise everything else would go towards red, and that's not what we want. But well, let's animate the color. We could make it change all the time. We could just make it float between values, and that's totally what we can do, but I'm not going to do it a bit differently. But what we want to do is ask the entity, which color should this core be? Droid.getRed color. We could ask the droid itself to just give us a color with all the information, and then we could extract all the different color parts from it. But to do so, what we would have to do would work with binary and bits and bit operators and so on, and that's the next course, so I don't really want to get started with that now. That would just be confusing. So what I'm going to ask it for is 3 different components: the red component, the green component, and finally the blue component here. Get blue color, like that. And this is the core, so maybe if you want to, you can call it like get red core color, but I don't think I have to bother about that. It feels like it's quite obvious what colors those are, but you can totally do that if you want to. It's just what you name them to. And get blue color like that. Create method get blue color. There you go. Sweet. So now it's just a matter of returning it here, and then it's going to use that for the core itself. What I'm going to do is just randomize the colors. I think that's good. But if I randomize it all the time, recall it here, well, then it's going to change color all the time. It's just going to blink. It's going to be terrible. If you're evil, then you can do so. Well, I'm not evil, not right now at least. So what I want to do is just private float R, private float G, and private float B, like so. So RGB, red, green, and blue, like so. And if we wanted this droid to have the same color of its core all the time, we would obviously generate that on the server side. The server would save it and so on, and then the server would give it to the client, so the client can render it, and then all the clients that watched it would see it in the same way. This is just an example. I'm not going to bother about that. So what I'm going to do is just randomize it on the client side, and therefore we will have 2 problems. Or well, problems and problems. I don't know if they are problems, but what we'll have is if multiple players look at this droid, then they will probably see, or will most likely see, different colors of its core. And secondly, if we relog, we will see a different color of the core of our droid, so it's not going to be saved. But the only solution, the solution is very simple. Just store it on the server side and give it to the clients. R equals world.rand.nextFloat. So I just randomize the red part. G, I do the same thing here. Rand.nextFloat. I randomize that part as well. And the blue should also be randomized. But like I said, this is going to be different each time you log into the server, or each time, well, for each player. Up there, and then it's just a matter of logging in here. And now we should see it being a bit more colorful, but it's not. So why is that? You may wonder, and I don't actually have a clue. Let's take a look. So what we do here is that we randomize these colors here. We just get the next float there, and boom, oops, we might want to return them as well. So I messed up a bit. I'm sorry about that. So as you can see, if we have 0, 0, 0, that's obviously black, and therefore all the cores turn black. But that's not what we want. So let's restart. Sorry about that. But as we saw last time, the entity itself was actually controlling the color. We returned 0, 0, 0. But obviously what we want to return is the values we have randomized. And there you go. Now it looks much better. And it actually looks a bit more creepy, because now we can see that, well, these are not only droids that look exactly the same. They have some sort of character and looks a bit different. So something is going on here. Maybe they are invading. I don't even know what these guys are anymore. But we have seen a lot of different things here. We have something spinning there inside, and we have different colors depending on which droid we have. If we wanted to, we could of course change the colors dynamically, so one droid doesn't keep its specific color. It changes depending on maybe how much fuel it has, how much power it has from the solar panels. Obviously it doesn't generate any power from the solar panels at the moment, but we can implement that and then change the color depending on that if we wanted to. We see the rotation, we see the movement of this helmet thingy, and we have simulated a well, making the pillars longer by having them very long at the beginning and hide that inside the main block like that, and then they just go up and down. And we have also seen the rotation like this, a more advanced rotation where we have the outer one retracting first and then the inner one is retracting like that. So there we go, that's pretty much it for the animations. If you use these things, if you all put them together and design everything properly, then you can do very, very advanced things with these guys. But before we end this well, this lecture, I'm just going to have a short summary of what we've been talking about, more specifically with the code. Okay, so first of all, we well, talked about how do we make an animation itself. Well, the major part is modify the value of a model renderer. Here we set the rotation angle depending on well, whatever the core should be rotated at, but we do that before we do the rendering. So we do that in the rendering method, but before we actually tell all the model renderers to do the rendering. So that's the important part there. So just modify that each time you want it to be rendered. But of course, the rotation itself should be updated all the time from the entity, so that is being rotated properly. Then we also saw how we could use child models to sort of make them follow along. Here we have the inner panel and the outer panel. Some code has been removed just to keep it a bit simple here. But what we have here is the inner panel that has its box and its rotation point and so on, and then we have the outer panel which also has a box and its rotation point, but it's a child to the inner one. That means that when we rotate the inner one to open up the solar panel, then the outer panel is going to follow along. And as we saw just in the example right before this, we saw the inner one extract, and then when that had extracted, we extracted the outer one afterwards, so it followed along first and then it extracted itself like so. And this is exactly what I just talked about. So if the solar panels should extract, we use the server and synchronize that data to the client. Then we first extract the inner panel, and then if that has reached the outer point, then we extract the outer panel. And then when we retract it, we first retract the outer panel, and when that has reached its very close location, then we rotate the inner one as well, so to retract that. So as you can see, we might need quite a lot of code to update the rotations and so on, but that's all about how do we want to calculate these rotations, where should they be, how should we render them and so on, and then we just use these angles and apply them to the model renderers like we saw before. We also have this part here where we simulate resizing that I was talking about. So just to move things, that's the same when we move things. We just update the rotation point Y, X or Z or something like that, and we're basically going to change the position. But when we wanted to simulate it that it changed size, what we had was to hide the pillars inside the main block, and then when we moved them all up, it looked like they well, we're getting bigger and bigger, and then when we move it down, more and more were hidden there. But the important part here is that we don't have two boxes that are in the exact same position, so their faces sort of overlap, because then the rendering code won't be able to tell which one to render. It blinks, it's not good, it looks ugly, and so on. But we fixed it like this. We set the pillars to have this size 3.995 rather than 4, so that's just a tiny difference. So we can't tell it ourselves, but the rendering code will know which thing to render, and therefore everything will look good and work perfectly fine. And that's pretty much it for today. Don't forget the questions in the exercise document. We have the questions to see if you've learned all of these things, and an exercise to practice this, and as well a further exploration if you want to go even further with this, maybe use some things that hasn't been that I haven't been talking about during this lecture. And there will of course be answers to the questions and possible solutions to the exercises. But that's pretty much it. This has been the anatomy of a Minecraft model, lecture number 2, animations. I've been VSWE, and I hope you enjoyed it. Next time we'll take a look at how we can do it with blocks, and how we can make sure that items are being rendered. For instance, we'll take a look at how we can make our drawing droid being animated as a droid when we hold it in our hand, not as that icon that we have now. But that's next time. I hope to see you then. Goodbye.